I want to talk about scientific notation, and you're going to love scientific notation because it really takes the guesswork out of how many digits are significant. Because if you are looking at a number in scientific notation, all of the numbers shown are significant, with the exception of the exponent stuff. Let me tell you what I mean. By definition, a number in scientific notation has only one digit to the left of the decimal, and then it may have any number of digits to the right of the decimal, and then you have this times 10 to the exponent thing over here. All right? When you're trying to figure out how many digits are significant when a number is written in scientific notation, put your hand over the exponent thing because we're not looking at that. Just looking at this, if I show 3 digits, then there's 3 significant figures. Okay? Let's look at an example from form number 1. And what this version of this worksheet wants you to do is to first convert to scientific notation and then indicate the number of significant figures. So when you write it in scientific notation, you're only supposed to show the number of significant figures. If you were to write this in scientific notation, you know that you can only have one number to the left of the decimal point. So that had to come from over here, 1, 2, 3. So you would rewrite this number as 2.306 times 10 to the 3. Okay? So this in standard notation is this number in scientific notation. Now, this number was significant, this number was significant, this is significant because they're non-zero numbers. This 0 is significant because it's trapped between 2 significant figures. So there's 4 significant figures here. And in fact, when you rewrote it in scientific notation, you include all those 4 digits, and there are 4 significant figures. You would indicate that in the worksheet in parentheses, just like that. Let's take an example from form number 2. 4900. Now we need to be careful with this one because these zeros just look like they're holding place. All right? So when we write this in scientific notation, if we were to just follow our instincts, follow our freshman instincts, we might write it like this. But now we've just made these numbers, these zeros, significant because we showed them. We really can't show them because when the number was written in standard notation, these zeros really are not significant. Right? So there's really only 2 sig figs right here, so we can't show that when we write it in scientific notation. Okay? See how this can get kind of tricky? If you do several examples, and we will, I think you'll be fine. Let's take another example from version number 3, 0.00589, written in standard notation. These zeros are leading. These zeros are to the right of the decimal, and they're leading. They're only holding place. So this is not a significant digit, and this is not a significant digit. So let's just be aware of that up front. When we convert this to scientific notation, we're moving the decimal point 1, 2, 3 over to the right. So this number would become 5.89 times 10 to the minus 3. We've only written 3 figures here, and all of those 3 are significant. Okay. All right, next one here. Let's look at version 4. We're going to take another example. $121.0. Whoever took this measurement is trying to tell us that this was precise and they left this trailing 0 to the right of the decimal. It is significant, so we need to make sure that that is retained when we write the number in scientific notation. So 121.0, again, we can only have one digit to the left, so we have to move it over 1, 2. So this number becomes 1.21. We got to write that sig fig times 10 to the 2. Okay? Again, there are 1, 2, 3, 4 sig figs here. If we show it in scientific notation, it's got to be significant. All right. The last question on the worksheet is, take a number like this that has 3 sig figs and now rewrite it with only 2 significant figures. Why would you ever have to do that? Well, if this number was the result of a calculation and one of the terms in the calculation only had 2 sig figs, then you have to reduce your answer to 2 sig figs. The only way to write this number with 2 sig figs, you're going to have to round. When you round to a certain number of sig figs, here's how I do it. I say, okay, I can only have 2 sig figs, so I'm going to come over here and I'm going to look at the most significant figures. I got 1, 2 here. I can only have 2 sig figs. And then I look to the right of the last digit that I underlined, and that's a 9. If it's 5 or more, you round up, right? So this number is going to become a 1. So I'm going to write, in scientific notation, 1.1 times 10 to the 2. In standard notation, 109 with 3 significant digits becomes 1.1 times 10 to the 2 in scientific notation with 2 significant figures. Maybe we better do another one of those, right? Let's try from version number 2, write 219, which has 3 sig figs with only 2 sig figs. If you were to write this number with 2 sig figs without it being in scientific notation, you could do that, right? You could write this number by rounding it up. So here's 2 sig figs. You look to the right to see if you're going to round up and round down. You're going to round up. This actually becomes 220, right? There's only 2 sig figs here, right? And it's pretty close to 219, right? So, but that's not scientific notation. To write this in scientific notation, we only write the significant digits. So it becomes 2.2 times 10 to the 2. Okay? All right. Let's go ahead and do the rest of these on this form. 749, which is 3 sig figs. Well, let's write it with 2 sig figs. Again, we can only have 2 sig figs, so we need these two digits, but we don't know if this one is going to stay at 4 or round up. Well, it is going to round up, 750, and to write that in scientific notation, that would be 7.5 times 10 to the 2. All right, and the last one, we're going to write 199 that has 3 sig figs, and we're going to standard notation with 3 sig figs, and we're going to write it in scientific notation with 2 sig figs. So this one, I know that I need 2 sig figs. I'm going to look to the right and see if it rounds up or rounds down. This actually rounds up to 200. Well, this only looks like 1 sig fig, doesn't it? So, how am I going to write this with showing only 2 sig figs? That's why I'm asking you to write it in scientific notation, because sometimes it's the only way you can write a number and show the proper number of significant digits. So this in scientific notation would be 2.0 times 10 to the 2. The value of the number is correct, and I'm showing the correct number of significant figures. Okay? All right, that's some pretty heavy-duty stuff. You didn't think determining the number of significant figures was going to be too hard, but when you're dealing with scientific notation, it brings a level of complexity up to it, but it also makes things a lot simpler, because if it's shown, then it is significant.